We're going to use properties of logarithms to rewrite expressions that have logarithms. So we're going to start out with our product property and our quotient property. So product is the word we use to describe multiplication, and quotient is the word we use to describe division. So if I have a logarithm expression where the argument is a product, I can rewrite this as a sum of the log of the first factor plus the log of the second factor. I'll show you in a minute how this looks. Let's see. So here's an example of using that product property. I've got a natural log of 3e, right? This is a product right here, right? It is saying multiply 3 times e. So my product property says that I can change this single natural log to the sum of 2 natural logs, right? So along as the way here, our bases have to stay the same. So the natural log of 3 times e is equivalent to the natural log of 3 plus the natural log of e. Right? And that's what our product property does for us. Right? Now I would call this expanding this expression. Right? We went from a single log expression to the sum of 2. That feels like we're making it bigger, right? We're expanding that. Now, as you do these, I always want you to simplify if possible. So right here, I have the natural log of e, right? So this is a base e. This represents the exponent we raise e to get e. Well, that's just 1, right? So this is one of our properties with zeros and ones. And here's my final expanded result there. Right, so I'm going to simplify natural log e to just that constant 1. So there's an example of using the product property. Right? We also have our quotient property for logarithms. Quotient is the word that we use when we're dividing. So if I have log base a of x divided by y, this property says we can rewrite it as the log base a of the numerator minus log base a of the denominator. And again, I would consider this an expansion going from this side to this side. Before we're done here, we're going to look at problems where we start with expressions like this and we condense them. All right, so it could be used either direction. And we've got an example of this quotient property. So if we're going to come over here, we're going to look at an example with a quotient. Here I've got the argument is 25 divided by y. So our quotient property tells us that we can expand this and write it as log base 5 of the numerator minus log base 5 of the denominator, right? So just following this exact pattern. I feel like that's an expansion because we went from a single log expression to a difference of 2 log expressions. Now here, I am also going to want you to simplify whenever you can without using a calculator. So let's look right here, log base 5, 25. Right? This is the exponent on 5 that results in 25. So we're going to remember logarithms equal exponents and then make that evaluation. All right, this is the exponent on 5 that gives us 25. So our final form is going to be 2 minus log base 5 y. Now for the next 2 examples here, we're going to need another property. So let me expand a little bit here. We've got our product property, our quotient property, and now we're going to look at the power property. This says that if we have the log with an argument raised to a power, this exponent can come down and be the coefficient, right, or the multiplier of that log expression. So let's see what that would look like with our example right here. All right, so this matches that format. This power property says that that power of 2 can come along and be the coefficient here. So this is equivalent to 2 log base 12x. Now we're going to have some problems that ask us to use more than one property at a time. So let's come down here and let's keep up with this rewriting using our properties. And if I see a single logarithm at the beginning, then I'm going to think that this is an expansion that we'll be working on. So let's tackle this one right here. We have log base 4 of 7 cube roots of 4. Right. Now this is a product, right? If we have no, sorry, let's focus there a bit. This is a product. If we have no plus or minus between, then it's implied that we have multiplication here. So let's think about our product property first. This is going to give us log base 4 of 7 plus log base 4. And as I write this next argument, I'm going to go ahead and change to exponent form. Right? So a cube root is equivalent to a 1/3 power. So our product property said since we're multiplying, we can change this to the sum of these two separate logs. And let's see, anything we can simplify? Let's see, 4 raised to what power gives me 7? I cannot do that without a calculator. I'm not going to do anything there. How about here? 4 raised to what power gives us 4 to the 1/3? This can be simplified, right? This whole expression represents the exponent on 4 that results in this. So that simplifies to 1/3. Let's try one more here. Now we have a common log. All right, so just notice here, if there's no base, we're going to call that a common log. It has base 10. All right. Now, I think the easiest way to simplify this is to use a rule about radicals. If I've got the square root of x cubed over y, that's equivalent to the square root of x cubed over the square root of y. All right, so that is just a rule about quotients inside radicals. All right, we definitely have a quotient. I think it's easier if we just break it up this way from the beginning. So if I have a quotient, I'm going to use my quotient rule. The quotient rule says I change this to the log of the numerator minus the log of the denominator. Now, along the way, I'm going to make the changes that we did before. If I have a square root, that's a 1/2 power. Now, it already has a power of 3. So putting the 3 over 2, this shows that we also are doing the square root. And then we're going to subtract log, common log, and the square root of y, I'm going to write as y to the 1/2. And so we're really relying on those fraction exponents instead of the radicals. Right. Up here, we've got a power of 3, so that's our numerator, and a square root, so we have 2 as the denominator. And now let's see. So the unwritten base here, which I'm just going to write in to remind us, is base 10. So I cannot do any simplifying. This certainly is not base 10. This is not base 10. But we are going to use our our power property here. If we have this exponent, it can come and be a coefficient. This exponent can come down and also be a coefficient. So our final answer here is going to be 3/2 common log x minus 1/2 common log y. So we have been using our log properties to do these expansions. Now we also can use the log properties to condense. So here's an example, or some examples that we can rewrite. If you see more than one log expression, right, then we're going to consider the rewriting as a condensing. And you'll also see the directions. We want to write this as a single log with coefficient 1. Right? So for example, right now, I have 2 separate logs. Right? This is not a single log. And looking right here, this is not a coefficient of 1. So I'm not done with this expression here. So we're going to kind of use our properties backwards. If I see a coefficient, I'm going to bring it up and let it be an exponent. So this is log base a of 10 to the 4th minus log base a x. All right, so that helps get a coefficient of 1. But I still need a single log. So if I am subtracting, I'm going to be using the quotient property. The quotient property says I can write this as a single log base a, and then we're going to have 10 to the 4th. So 10 to the 4th is 10,000 over x. Right. So just previously, we started with expressions like this, and we separated it into the difference. All right, so this is just working the other direction. Right, there we go. We have written this as a single logarithm with coefficient 1. So let's come along over here, see if we can work the same thing. I see coefficient 1 there, that's fine. Coefficient 1, that's great. Oh, but then I've got coefficient 8. All right, so we're going to use our power property first and call this natural log 9 plus natural log y minus natural log 8 raised to the x power. That's helped me get all of the coefficients to be 1. But I still need to condense, so I have a single log. Right? I have 3 separate log expressions right now. So let's go step by step. This addition means we can use the product property, and I can write this as a single natural log of 9 times y. Okay. Now you notice here, I've just changed to putting my argument in parentheses. I think it's just a fine practice to help remind us what the argument is. All right. I would not count it wrong if you did not use the parentheses here, but it makes it clearer. And now we've got subtraction. Well, this is a quotient property then. So if I have natural log of this minus natural log of this, we can write a single natural log of 9y over x to the 8. Right? That would be our single log, right? Our single log with coefficient 1. Now, just to emphasize, the subtraction can be a little bit tricky when we do our quotients. So let's take a look at this example here. I've got log base 4a minus log base 4b minus log base 4c. I think here the parentheses for the arguments would help me a little bit. See what each of those arguments are. Now, I do not have any power properties to take care of, right? I've got coefficient 1, or sorry, coefficient 1, coefficient 1, coefficient 1. But let's go right to our quotient property. If I go left to right, I see the subtraction. And I'm going to rewrite this as log base 4 of a over b. So that's showing that quotient property. We still have to subtract log base 4c. And now we are going to do the quotient property again. Right? Now this is where it gets a little tricky. Okay, we're going to use the quotient property again. Okay. So I can write this as a single log base 4. And then we're going to have a over b divided by c. Now, I'm going to write this horizontally just because of the fraction that we have anyway. I think it works across a little bit clearer. All right. So this is the numerator here divided by that second argument of c. Okay. And what I'm going to do here is use the rule that if we are dividing by c, it's equivalent to multiplying by the reciprocal. So I like having it horizontally. The fractions, I think, fall into place better. This is this divided by this, right? So a over b divided by c, equivalent here. This is going to give us our single log base 4. The numerator is a, the denominator is bc. And there is our condensed expression. Now, a shortcut here as you go along, anytime you're subtracting, those arguments are going to be in the denominator. So we saw that up here when we had a minus natural log x to the 8, right? That was the only subtraction, right? This was a positive natural log 9 plus natural log y, and then minus natural log x to the 8. The minus, the subtraction, is going to be in the denominator. Right? In this expression, we had 2 that we were subtracting. We were subtracting log base 4b. We were subtracting log base 4c. Both of these, the b and the c, will end up in the denominator. Okay, great. So we have rewritten using our log properties and in the direction of condensing.